Okay, now we're going to go ahead and solve logarithmic equations. In this particular case, we have one log on the left, one log on the right. When you have one log on each side with the same base, then you can go ahead and drop your logs. Just make sure you don't drop that log in your foot or that'll hurt a lot. So we're going to take what's after our log, set it equal to what's after this log. And then all we're going to do is just solve this. So we can go ahead and add an x to both sides, subtract a 4 from both sides. Then all we have to do is go ahead and divide. Now once again, remember, whatever's after your log ends up having to be positive. So we got to check our answer. Does putting in a negative 3 over 2 make this highlighted part positive? So negative 1.5 plus 4 is positive. Over here, 1 minus a negative 1.5 would be 1 plus 1.5, which is positive. So that works. So it doesn't make a difference if x is positive or negative. It's only when you plug it in after your log, if it's positive, then it works. Similarly, on the right side over here, once again, we have one log on the left, one log on the right, both with the same base, so we can go ahead and drop your bases. Set the parentheses after your logs equal to each other. Then we could go ahead and subtract an x from both sides, go ahead and divide, and we get negative 1. Now we got to make sure that since we started out with a logarithmic equation, that we check to see if whatever's after our log ends up being positive. So we want to take our negative 1 and plug it in to both spots. We take a negative 1 minus 5, that's negative, so that's not going to work because whatever's after your log has to be positive. Can't even be 0. So the negative 1 doesn't work, so we just say it's the empty set. So to summarize it, once again, whatever's after your log has to be positive. So make sure you check your answers. And when you have one log on each side with the same base, then you can drop your logs. But once again, just don't drop it on your foot. So here we don't have that situation. We don't have a log on both sides. We only have one log, and that's on one side. But keep in mind, we can still solve this because when you look at your base here, you're like, there's no base written. But remember, if there's no base after a normal log, that's a common log, which is a log base 10. Now, all we have to do is change it from the logarithmic form into the exponential form. So basically, we got to take our base right here, swing it over to the other side, and it hits that negative 4 up as your exponent. So we're going to have 10 to the negative 4th power equals whatever was after our log. So I call this the Tarzan move because we're swinging this over just like Tarzan swings through the trees in the jungle. Or you can go and use your definition of a logarithm, but it accomplishes the same thing. Now we need to finish getting x by itself. To finish solving x, we'd have to go ahead and take the square root. So we're going to take the square root of both sides, but remember the square root is really raising it to the 1/2 power. So we have 10 to the negative 4 raised to the 1/2 power. We have an exponent raised to an exponent, so remember in that situation you can multiply your exponents and we get negative 2. Also remember when you take your square root, the plus or minus. So this is really plus or minus 1 over a 10 squared or 100th. Now, we got to check our answer because we started out with a logarithm. So we got to make sure whatever is after our log is positive. We take our 1 over 100, plug it in here, and square it, it's positive. Even if we put in a negative, because we're squaring it, it's going to be positive, so that will work. On the right side here, up here in the exponent, we have two things multiplied together. We have our x multiplied by our natural log of 2. We can multiply in any order we want. The reason I want to do that is because I know e and ln undo each other. Remember, natural log is really log base 2, or log base e. So these are going to undo each other, leaving you just with a 2. So whenever your base here matches your base after your logarithm, and once again, your natural log is the same as log base e, these cancel out, leaving us with just 2. So it ends up being in the parentheses 2, still raised to the power of x. Now we can finish solving this. Now there's a couple ways you could do it. We could use logarithms here, but you don't have to. You can think of your 1/4 as being a 1 over 2 squared, or since that 2 squared's on the bottom, you can bring it up to the top and it just becomes a negative exponent. Now you have 2 to the power equaling 2 to the power, so you can just say, well, the exponents have to be equal because the bases are the same. And we get negative 2. Now this one here, we don't have to check because we did not start out with a logarithmic equation and a variable after that log.